See, there may be some catalytic particles or catalyst, whatever you say, which may decrease this rate of reaction. Decrease rate of reaction. These catalytic particles are known as inhibitors. Let's move forward and see. Let's take this example. Our example, A plus B gives C. See, as these reactants are going to produce C, that means these reactants before producing C should have some minimum possible energy, and that energy is known as activation energy. See, let me give a common example. Let's take a child and he has to cross this wall. So here is its home. So before he can reach his home, he has to cross this wall. Same happens with these reactants. Before they can produce C, they should have a minimum possible energy, and that energy is known as activation energy. These reactants, these A plus B, should possess this maximum, or their energy should be raised at least to this energy, activation energy, so they are in the position to produce products, and in this case product is C. Now what this catalyst actually does, it, for example, see, there is energy from this side. Let's see it on a plot, and this is the progress of reaction. See, let's say this, at this point corresponding to this is the energy of reactants, and from this energy, this much is the energy barrier. That means these reactants should raise at least this much energy. So from this stage, at reaching this energy level, it will be here, this energy level, this energy will be activation energy, EA, and then they will try to form products, and products will be at the lower energy level than the reactants. These will be products. I think I should answer this. Reactants, why reactants are at higher energy level than products? See, if the reactants are not at higher energy than products, first of all, higher energy means less stability. Higher energy means less stability. That means reactants try to produce C. That means they try to move to more stable state, and that is C. More stable state means less energy. That means the reactants should be at higher energy, this higher energy, than these products. I hope it's clear. If it's not so, there will be no reaction. This will not be a spontaneous reaction actually. See, when this reactant is at higher energy than product, everything flows from higher potential to lower potential. It's a basic law of nature. That's why these reactants try to go to the lower possible state energy, this product state, and before doing so, they should possess this much energy, and this energy is known as activation energy. Now what is the role of this catalyst? Actually, this catalyst, when it's added to the reaction, it decreases this energy barrier. For example, before the catalyst, the reactants should possess this much amount of energy. Now this much amount of energy is actually the energy barrier. Energy barrier. Now as we add the catalyst, it will try to decrease this energy barrier. Now reactants need only this much amount of energy to form product. This is the reduced energy barrier. Reduced energy barrier. This dotted line is for catalyzed reaction. Rxn stands for reaction. This is the progress of the reaction, and on this scale it's energy. I hope it's clear. Catalyst actually decreases this energy barrier. Now let's talk of this catalysis. Basically it's of two types. First is homogeneous catalysis, and second one is heterogeneous catalysis. Heterogeneous catalysis. Now what do you mean by this homogeneous catalysis? Let's take an example, A plus B in presence of some catalyst. Now we show catalyst here, for example it's C, and these A plus B in presence of this catalyst C gives D. Now when this A, for example, it's present in gaseous state, and this B, it's also present in gaseous state. This catalyst, when it's also present in the gaseous state, now this type of reaction in which we use catalyst which is in the same phase as the reactants are, this type of catalysis is known as homogeneous catalysis. And if we take an example like this, A plus B, suppose this is gas and this is gas, and we use some catalyst D which is in solid state. Now this type of catalyst is known as heterogeneous catalysis. I hope it's clear.